Okay, so this is the last video for section 5.1, and where I want to start with this is I want to refresh you. What does the graph of y equals tangent x look like? Well, if you remember, the standard period was from negative pi over 2 to pi over 2, and what we had was, if you remember, at negative pi over 2 and pi over 2, tangent was undefined. Tangent was undefined. Okay, so what we ended up with here was if you remember, this was negative pi over 4 and pi over 4. And so we had pi over 4, 1, negative pi over 4, negative 1, 0, 0. And so that's a horrible tangent graph, but it looks something like that. Please excuse the horrible graph if you want a computer aided one, you can look in your book there. But the domain of tangent was from negative pi over 2 to pi over 2. Now notice these are parentheses, not brackets. So that means it will never reach negative pi over 2 and pi over 2. And the range was, of course, all real numbers because of our graph shooting to negative infinity and positive infinity. So what happens then if we want to graph y equals the arctangent of x? Well, remember, since we interchange our points, our x and y coordinates interchange, if you remember. So this would be pi over 2 and negative pi over 2. And this would be negative 1 and 1. Now, it's important for you to go ahead and note that the domain and range, remember, they swap. So the domain of arctangent would be all real numbers. And the range would be from negative pi over 2 to pi over 2. Now notice we're not touching pi over 2 and negative pi over 2 again. So we still have this undefined line here. Now remember, to get the other points, we can just interchange the x and y coordinates. So really, your tangent graph should end up, your arctangent graph, excuse me, should end up looking something like this, if done correctly. Okay? So, what do we say? What does that say about arctangent? Well, or inverse tangent. Well, we know that y equals the inverse tangent of x or arctangent x, either way, when the domain is restricted from negative pi over 2 to pi over 2. And that's equivalent to saying the tangent of y equals x for all y in this interval. For all y in this interval. Alright, our inverses, just like sine and cosine, we do have inverses. So the tangent of the inverse tangent of x is going to equal x for all x. Now that's going to make it easy there. That's going to make it easy for us. However, be careful, because the inverse tangent of tangent x equals x only, well, Have no idea what happened there, folks. I'm sorry about that. The inverse tangent, just rewind it if you want to see what I had originally. I'm going to rewrite the second one again. The inverse tangent of tangent x equals x only if x is in negative pi over 2 to pi over 2. So that's the one you've got to be careful with. The other way was all real numbers, but this is the one you've got to be careful with, okay? So let's look at a few examples. So let's try to find the inverse tangent of negative 1 over the square root of 3. So remember, that's asking yourself, what y value in negative pi over 2 to pi over 2 has a tangent of negative 1 over the square root of 3? What angle has a tangent of negative 1 over the square root of 3? And remember, it has to be in this interval. The angle has to be in this interval. All right, so because of that, and because it's negative, we can make our reference triangle. We know this is quadrant 1 and 4, this interval. So we know it has to be in quadrant 4 because it's negative. So make your reference triangle here. This will be negative 1, and this will be square root of 3. Because remember, tangent is y over x, or sine over cosine, remember. Take your Pythagorean theorem, and you can very easily get the hypotenuse if you need it. Hopefully you don't need it at this point, because hopefully you realize that this angle right here is going to be negative pi over 6. Okay, that's the pi over 6 angle. All right, so if we did do the Pythagorean theorem, that gives me 3 plus 1 equals 4, which equals c squared, so it has to equal 2. Okay, so this is actually the point, if you're thinking of it in terms of the point so that you can relate it back to the angle on the unit circle. This is the angle square root of 3 over 2, negative 1/2. So what angle has those x and y values, has those sine and cosine values? Well, that is going to be negative pi over 6. Now, the answer you're going to come up with if you look at your unit circle is going to be 11 pi over 6. But why can't we choose 11 pi over 6? Because it's not in our interval here. It's not in our interval. We have to find the angle in that interval, which is negative pi over 6. All right, so let's look at another. Let's look at the arc tangent of the tangent of negative 1.2. All right, well, first and foremost, this is the formula that goes with this one. Arc tangent of tangent x equals x if x is in this interval. Should be parentheses, not brackets. I've been used to writing brackets. All right, so now, what you need to do is take negative pi divided by 2 and get the decimal form. Take pi divided by 2, get the decimal form, and see if negative 1.2 is in here. And what you find out is yes, it is. So this fits the identity. So we know the answer is negative 1.2. All right, well, what about this one? Let's do the inverse tangent of the tangent of pi. All right, well, pi is not in that interval. So we can't just say it's x. We can't just say the answer is pi. So what is the tangent of pi? Well, remember, pi is the point -1, 0. So the tangent of that is going to be y over x, which is 0. So that's the tangent of 0. So what we're actually trying to figure out here is what is the arctangent of 0. So what angle in this interval has a tangent of 0? What angle in this interval has an angle of 0? So what you have to do is we have to look at our unit circle and look at 0. Look at 0. So, excuse me, not 0. Look at, I don't know what I'm thinking. Look at pi over 2. Pi over 2 is the point 0, 1. Okay. Well, if we do that, that's arctangent. So we're trying to figure out what angle equals 0. So we got to figure out all the angles that have a tangent of 0. So the only way you can have a tangent of 0 is if it's on the axis. So that's why I'm starting with pi over 2. What is its tangent? Well, its tangent is undefined. Negative pi over 2. Its tangent, undefined. All right, well, the only other axis we have in this interval is at 0. So at 0, we have the point 1, 0. So that's 0 over 1, which is 0. So this is our answer here. The tangent of 0 will give you 0. So our answer to this problem would be 0. Remember what you're asking yourself. When you rewrite it, remember what this is saying. The tangent of what angle is giving me 0 in this interval. Okay? And the only one that does that is 0. Notice, I went through and I checked all the axes first, because a tangent of 0 can only happen on an axis. Okay? So that's why I checked all these axes first. So make sure you remember that. That'll be a quick trick for getting this done. Now, if you remember that at pi over 2 and negative pi over 2, tangent is undefined, you only have one axis to check, and that's 0, right? So if you can use your logic about what you know about the tangent graph, it'll help you make this go a little quicker. All right, so again, on page 299, there are some calculator problems I want you to try. Try them yourself. Make sure you can type them in the calculator and get those answers. Okay. So last but not least today, for section 5.1, here's what I want to do. I want to take this problem and express it as an algebraic expression in x. So I want to express as an algebraic expression in terms of x. In terms of x. So I'm going to let y equal arctangent of x, which is from negative pi over 2 to pi over 2. Or equivalently, what we're saying here essentially is the tangent of y equals x, which is the same thing as x over 1. And this is where y is from negative pi over 2 to pi over 2. Alright, so here's what we want to do. Let's draw our reference triangle, just like we do when we do these problems normally. we're going to use what's inside to get our reference triangle and then take the sine of it, just like we did with the problems with sine and cosine. So because this is x over 1, I'm going to draw it in it's a positive x, so I'm going to draw it in quadrant 1. Okay, we know that this is 1 and this is x, because this is the same thing as y over x, remember? So we need to figure out what r is right here. What's the hypotenuse? Well, if you use your Pythagorean theorem, you're going to get r to equal x squared, the square root of x squared plus 1. So now, here's what we know. Because we've done this, we know that the sine of y, remember, y is arc tangent of x, so we're going to replace that. So the sine of y equals, all right, so use your reference triangle that we got from arc tangent x to find sine. So sine is going to be opposite over the hypotenuse, which is x over r, and we know now that r is the square root of x squared plus 1. So that is your sine y. All right, so that little formula right here will come in more handy for those of you when you get to calculus, okay? So that'd be something good to remember. All right, so that ends section 5.1. At the end of section 5.1, starting on page 300, there's a good summary of everything I did here. I would make sure and commit that to memory, that summary. And I will see you in section 5.2. Please ask if you have any questions.